Hi, in this video, I'm gonna walk you through on how to solve some problems with regards to zero order reaction. We're gonna use this example over here. Given X aqueous to be making products, the decomposition of X will have the rate constant of 2.10 times 10 to the power of -4 with the unit of molar per second. There are two things that you need to do. Number one, A, we need to find out how long will it take for the concentration of X to fall from 1.20 molar to 0.350 molar. Second, we need to calculate the half-life of another initial concentration of X, which is 0.245 molar aqueous solution of X. Now, we're going to start with A. To do A, the first thing you need to identify is we need to know what type of integrated rates equation we need to use. Either it's going to be zero, first, or second. If you read the question carefully, the question does not give you the information about which order to be used explicitly. So how are you going to do that? So you're going to look at the units of rate constant. Over here, the rate constant is that one. And when you look at the units is molar per second. Therefore, step one, we will be able to identify that this reaction is zero order because the K unit is molar per second. So we're going to use the integrated rates equation, the one in yellow. So we have initial concentration minus with the concentration at a given time equals to K times by T. Step two, we need to find out what the question wants, and we know that the question wants you to find the time taken for the concentration to fall from the initial concentration 1.2 molar to the concentration at a given time 0.350. So we have what the question gives. So the concentration of X here will fall from 1.2 to 0.35. From that piece of information, we can conclude that the initial concentration is 1.20 molar and the concentration at a given time is 0.350. So every single time, bear this in mind, if you have the word 2, okay, they want you to find from one concentration to another concentration. So we have to consider that the one here is going to be your initial, and the one that will be going to will be the concentration at a given time. So step 3, we need to write let A equals to X. This is a very important piece of information you need to include in your calculation. If you do not define what is your A over here, your calculation will be deemed as invalid and you might not going to be getting your mark that you deserve. Okay, so yes, we're going to use the integrated rates equation for zero order reaction because the units of rate constant right there is molar per second or molar per time. So you're just going to plug in all the value inside. I'll take 1.2 as the initial concentration as what the question has told you. And the concentration at a given time, 0.35. Plug that in right there. You're going to take the rate constant, put that into there, and we're going to be able to find T. So T will be 4047.62 seconds. In terms of marking, you will be able to get 1 mark for this. And then you'll get 1 mark for this whole thing over here. And also 1 mark for this whole thing right there. Okay. Moving on to the next one, B. So we have done A. So how are we going to calculate the half-life of the reaction? Right now you have to be careful because the question gives you a new initial concentration, which is 0.245 molar. So we're going to use this information instead. Okay, we're going to use this concentration to find the half-life of your solution X. So we have the 0 order half-life equation. So this is the equation that you need to remember for 0 order. So you have concentration, initial concentration over 2K. The value of K is still the same. Okay, we're still going to be using the same K value. So that is your K right there. 2.10 times 10 to the power of negative 4 molar per second. So when you plug that into the equation, like so, you will be able to get your half-life, which is 583.33 seconds. And always remember to write this to define what is your A, which is in this case an X, and the initial concentration that is given to you is right there for question B. So in terms of marking, you will get 1 mark for that. And for this whole thing over here, you get another 1 mark.